Good morning and good evening, everyone. Welcome to one another Saturday live session. And today's session is on MLOps with TFX pipelines. Thank you for taking time out and being here today. I would like to introduce today's presenter, Hasan Rafiq. Hasan is going to deep dive on TFX component for MLOps. Followed by that, he will show us on how to build an end-to-end pipeline, end-to-end machine learning pipeline using TFX. Hasan is a cloud and ML architect bringing rich experience with Google Cloud Platform as well as wealth of knowledge on machine learning and TensorFlow in specific. This is also third session Hasan will be taking on AI engineering channel. The previous two session is also on the similar lines. He had an end-to-end deep dive on TensorFlow and then TensorFlow machine learning certification guide. Please join me in welcoming our speaker and over to you, Hasan.
Thanks, Shri. And happy weekend, everyone. I hope you are enjoying the weekend and happy Holi to all my friends from India. So let's utilize this time for 1 hour that we have over here on the session to talk more about ML ops, in particular the TensorFlow Extended. And so far, TensorFlow Extended is a very undermined, or I would say like an underdog library which was launched like 2 years, 3 years back, and people were quite scared of TensorFlow Extended. So I thought let's discuss about TensorFlow Extended. Take a simple use case, talk about what it does, how is it different than TensorFlow, what is machine learning ops, and have a quick demo and see what it can do. So starting with a very small saying which we usually hear when we do machine learning for enterprise. So enterprise ML is not about the best model, or I can say enterprise ML is not Kaggle. Some people know this fact very well, that when you want to build machine learning for enterprise, then you have to do a lot more things than just building the ML code. And you can see it on the diagram here. So you can see whenever you build a machine learning end-to-end solution, it has so many components, and ML code is just a very small part in the whole pipeline or in the whole solution. Okay, so on the same line, when we know that there is the machine learning end-to-end pipeline is such a complex process. It includes configuration, automation, feature engineering, data collection, data verification, model management, model blessing. How can we make things easier for a person to do enterprise ML? And what are the best ways to do it? We have TensorFlow. We all know TensorFlow, PyTorch, Cafe. These are some of the frameworks which are available to train machine learning models. But when it comes to ML ops, and ML ops is a new term that I'm bringing in this session. ML ops actually means DevOps for machine learning, or when you're operationalizing machine learning models end to end. That is called as ML ops. So what, since Google provided TensorFlow, did they provide us anything else to do ML ops? Yes. And here we welcome TensorFlow Extended. So TensorFlow Extended is like an end-to-end platform for deploying production ML pipelines. It's somewhere between an ML ops framework and an ML coding framework. It's more like a layer between your ML ops and ML code framework. So it's somewhere between TensorFlow and, if some people would know, Kubeflow, for example. And I would say if someone is coming from the Kubeflow background or Airflow background, please don't confuse. TensorFlow Extended is not Kubeflow, it is not Airflow, and it is not MLflow. It is slightly different than those environments and those frameworks. So let's talk about TensorFlow Extended, what it is and what it does. So if you see, and I'll compare it, keep it in contrast with what we usually do in frameworks like TensorFlow or PyTorch or scikit-learn. In whenever we want to build a model on PyTorch or scikit-learn or TensorFlow, what we have with us is a data set, we have a problem statement or a model, and we have a finally trained model which we deploy. What we usually do is we write a training script to pick up the data. Either we load it in memory, or we write a dataset pipeline, which I have also shown in the same on the AI engineering channel in my first video, how to build an end-to-end pipeline on TensorFlow. You can do the same thing with TensorFlow, but when it comes to end-to-end MLOps, that means you have to pick up a lot of data from different sources like files or email, or web source, or let's say from BigQuery or from another warehouse. You may want to run some statistics like what are the mean, max variances, are the data correct, does the data have any anomalies, We may want to generate schema on the fly. We may want to validate the data to check for training, serving queues, and all those things. And then we may want to transform the data. Transformation means applying feature engineering, then train the model, evaluate how the model is doing. And then after evaluating the model, you may want to check if my final model, which has come out, is it better than the previous model that we have running on our pipeline, or is it not better? If it is better, then we move. Is the model servable? Is it light? And all those things. And you may be thinking, that is machine learning so complex? It actually is a little bit complex, but I won't say it's difficult. It's not rocket science. So since there are so many components, TensorFlow Extended provides us a very easy way. It's not that easy and it's not that difficult, but it provides us a very good framework to build this end-to-end pipeline, as you can see on the diagram in front of me. So all these orange boxes, these are actually components, and they are named the same way: example gen, statistics gen. So example gen is the one which picks up your data from your local file or from your BigQuery. It picks it up, it converts it into TensorFlow record files or TF-records files. It's the standard format which TensorFlow uses to convert data into an intermediate format which can be quickly read by TensorFlow at scale. Then it generates statistics on top of it: mean, median, max. This output then goes into example validation or schema gen. So the output from example generation or the TF record files and the statistics gens goes into the schema generation. So TensorFlow Extended comes with what is the schema of your file. So let's say it has 25 columns or 30 columns or 50 columns or 100 columns, and what are the different column types? What are the feature types? Integer, 32, string. If let's say it is categorical, then what are the possible values? Mean, max, min, mode. And then on top of it, you can write a transformation function. So this is another component. Result from transformation then goes into tuner or trainer. Trainer is the component wherein we write the training script, which is the main component wherein we build the machine learning model, either using TensorFlow estimators or Keras models. You can write any complex model. Um, there are no restrictions on that. And same, trainer connects with the tuner. Tuner is again that part of the TensorFlow library which trains our model, and hyperparameter sorry which finds the best hyperparameters for our model. So let's say what should be the learning rate, what should be the L1, L2 parameters for regularization, number of layers, neurons, or any hyperparameter that we want. And on top of it, after the model is trained, then it goes to evaluator component, which evaluates my test set with the model, comes up with the accuracies. Herein, you can also compare your model, current model, with the previous versions, or the current deployed model. And all these features are already built in this whole component set. You don't have to write that code. So it's actually easy. You can just pick up this whole pipeline, write everything, and just deploy it anywhere, either on Kubeflow. So let's say, so you can run TensorFlow on three environments. That possibly you can run it either on Airflow. Airflow is another component by Apache. You can run it on Kubeflow, or you can also run it on your local system, so as a file without any Kubernetes installation. So Kubeflow, some people would be knowing it here that Kubeflow is actually uh, MLOps environment which runs on Kubernetes. Airflow is an environment for orchestration. It's much more older than Kubeflow, which was built by Airbnb. And it provides you to build end-to-end pipelines, not only for MLOps, but you can build it for anything, any kind of orchestration that you want. It is used mostly for data engineering, data ETLs, and all lot of things. And once your model is ready over here, you can deploy it either as a TensorFlow Hub model, JS model, Lite, and TensorFlow serving. Best part again here is you don't have to write code for the specific deployments or saving. You just have to specify what kind of a model you want to save, and it gets done there. All right, so we've spent good 10 minutes to understand what is happening on ML Ops and TFX. I would like to dive deeper on how do we relate these components to the actual existing TensorFlow components. So we talked about example gen, let's say. Example gen is our first step or component wherein we ingest data. So there is no specific TensorFlow component which is required here. You just need a file. Now, for statistics gen, schema gen, and example validator, statistics gen creates the or computes the stats over my training data set or my validation data set, and schema gen generates the schema of my file using example gen and statistics gen. So this is done by the library called as TensorFlow Data Validation, or also known as TFDV. So I mean, it was new for me as well. I thought like a few months back that TensorFlow is the only library which is existing, but Google gave us a lot of libraries like TensorFlow, data validation, and all, which you can use either inside TFX or you can also use them independently for a lot of things. So TFDV is a very good library. It gives you back some plots and charts which we'll be seeing moving forward, that how you can analyze your data, the distributions of your data, features and everything, and you can see them interactively. You can check for anomalies, you can also check for drifts. So TFDV has a good feature. You can combine two data sets, and you can find drifts using sensing data distance or the infinite data distance. These are two industry level metrics to find the drifts between data sets. Then for transformation, or when you want to do feature engineering on a data set, you can either do in-model feature engineering, which is favorite for me, but you can also use the TensorFlow transform library. Now, when you use TensorFlow transform, this library runs the transformation code on top of Apache Beam. Apache Beam is again an open source framework to write transformation pipeline, which on Google runs on data flow component on GCP. Okay, and then the tuner and trainer components, they are part of the TensorFlow estimator and Keras library. After that, evaluator. So for evaluation of a model, you again have a TFML library, which is very good. It's a very good library. I actually found it very helpful. And you can also use the what if tool for evaluating the model. So these are very good libraries for evaluating your model. You can see different features. You can actually decode a black box very easily. And then for pushing and model serving, you have TensorFlow serving. So TensorFlow serving, most of you would be aware that you can serve a TensorFlow model directly on TensorFlow serving library or the TFMS, which you can run on any environment, be it even your mobile phone or your web server or your containers or anything of that sort. All right. I think I have talked a lot. People would be trying to run away from it, but sorry for that. And let's just move to some the interesting part. What we'll do next is I'm running this whole notebook on Google Colab environment without any GPUs, but you can run this on GPU as well. TensorFlow extended, TensorFlow libraries, they are very matured. They can handle GPUs and all everything. You don't have to worry. Even the TPU environments you can run over here. So what you can do next is you can install TFX, simple saying pip install TFX, and it is required because it installs other components as well. I've already installed pip, done a pip install TFX. I'm not going to run it again. And when you do pip install TFX, you'll have to actually run restart your runtime so that the libraries can take effect. What I'm going to do next is I'm just going to do a simple import of a lot of things which are required. So I'm using TensorFlow, model analysis, and all those things, but we'll also be sharing the notebook with you at the end of the session so that you can run the same code at your end. All right, we'll just give it a minute. Okay. By the way, just one information as well. I'm not sure how many of you are aware, but TensorFlow, Google Colab recently released their Pro version. So some of you would be seeing a different environment over here. You can start Colab with a much more RAM or disk, or even a more number of CPUs and GPUs. So that is possible with the Pro environment. Just a news to share. All right, we'll quickly check what are the TensorFlow versions over here. So 2.4.1 and TFX is 0.28. Good thing. What I'm going to do next is sanity. I'm going to make sure that I don't have anything already existing from my notebook. So I'm going to remove a lot of things. I'm going to create some folders over here. So TensorFlow needs a basic directory where it can work. So it needs a root directory called as TFX or something else. I mean, you can name it completely as per your requirement. Need not choose the same name. Inside it, you should have these 5 directories: pipelines, metadata, logs, data serving, model. I'll quickly show you. We'll refresh it and we'll see how it looks like. So these are the 5 directories. Currently, they are all empty, but we'll leave the TensorFlow extended to handle it. Now, as part of our session, what we're going to do is my favorite problem statement. Yes, it's a very simple problem statement, but it does a lot of things. So we are going to pick up the taxi data set. the same session, the same dataset which I also showed in my first session. And if people, some of you saw that session, you would be able to relate to what we are going to do next. It would be easier for you. But if you have not, you can watch that session as well and come back here, or even stay on this session and keep it simple. So the goal for today is not to dive deeper into what we are, how we are going to build the model, but what do we do beyond the modeling. So if you have to simply understand what we're doing in the model, then you can watch that session on AI engineering by me. All right, so we're quickly going to download the data set from here. Um, in a book, it got downloaded. What I'm going to do next is do a quick creation of data. So what I'm going to do, I'm going to create data in this format. So I have data right now available over here. But what I'm going to do is I'm going to create a new file called as a data trans. So I'm just going to delete my data and sorry, do a split of data into training and evaluation right before anything. And there are some questions which were coming earlier that why do we do a split before analyzing anything? I like it keeping it that way. As I want to split my data before doing any analysis so that it's more realistic. So it's personal. It's every person's opinion whether they want to do some basic analysis before splitting the data. But I prefer splitting the data and then keeping my evaluation set absolutely untouched and unseen. I've broken my data set into two pieces, training and evaluation. And what I'm going to do next is I'm going to do a quick check of what my file looks like. I'm sorry, I think I missed it out. Um, okay, we'll just skip that. And what I'm going to do next is, so I'm going to set some path variable. So I'm saying TFX root is the same directory, which is TFX, and then pipelines as this folder, logs as this folder, metadata. So TensorFlow needs a lot of these a lot of these folders. So it stores data inside this data, and I'll show you everything step by step. So I'll just give you an idea. It stores a lot of these artifacts in these directories. So it needs these files, and then I'm also going to create some Python files in between. I'm going to store some code so that it can be used by my pipeline everywhere, and we'll keep on talking about it. So some constants about file names are also created over here. For now, just you can assume that I created some constant, and we'll move forward. Now, best part about TFX is it can run on any environment, kubeflow, local, airflow. It can also run interactive. So I'm going to run it interactive right now. We'll see on our screen how it is running, and we can interact with it and see its components and the results. All right, I'll quickly run this thing. So here I got a message saying that my TensorFlow interactive context is run. Now I'll start with my first component. So I showed you the example gen is my first component. What it does is it takes my data or in the directory. So I'm telling that you have to pick up the data from data root, and data root is, if you can see, is TFX roots data folder. So this is this folder. Okay, and I've already placed a data trans file. Where did this come from? This came in from my code which I ran over here. So I picked up my data.csv file and put my training data inside this folder. Okay, but it's not necessary that your data should already be here. You can put it anywhere and set this path, data root part, as the third part of the folder where my multiple files are present. You need not only have one CSV file, you can have n number of CSV files. The component CSV example gen will be able to pick up all the CSV files that are there. Now, what does this component do actually is when you run this component, it will pick up the data in this file, in this folder, and it will convert the this all the data into TF records. So if I refresh this whole thing, you'll see a new folder got created by itself called as CSV example gen. Inside this, if I open, if I go inside, I'll see two splits. So it created train and eval further on my data set. If I go into train data, you can see there is a TF record file which has been placed by this component. Okay, so let's say if my data was not this small, in reality I would have been running either this either on airflow or kubeflow. There it would have run this step on Apache Beam or in local, and this would have got distributed into parallel. So if my data was, let's say, 10 terabytes or 50 terabytes or even beyond life, then it would have run this process in the background on multiple clusters to create or to convert my CSV file into TF records file. Okay, now since this is interactive, I'll quickly show you the output of the interactive TensorFlow extended. So this is a feature of TensorFlow extended. You can see the results of the components if you're running them in the interactive mode. So I'll close this one for a second. I'll again open this one. So it says that the output of this component is some files that got created in the CSV examples one gen folder, and it created two folders inside one, train and eval, and we can see them over here as well. Inside one it created eval and train, and inside that if we open, we'll have our files that are available. Okay, now we'll quickly also examine the output of the artifacts. If you want to do it from the code, we can say artifact is example gen dot output. So example gen is the output of the previous step. I'm saying pick up all the examples and print what are the split names and the folder names. So the same thing which I'm seeing over here, I can also access it via code. And I'm showing this because this is how we link the component. So the output of this component goes as the input of next component through these kind of notations only. So let's see if I want to go to my next component, which says which is the next one. But right now, what I want to do is I want to examine the data which is inside this file. So I've written a small code. Okay, what it does is it picks up the data from my training folder, this one, and it reads all the TFRecord files. It reads them in memory and picks up the first three records. Okay, this is standard code for TensorFlow to read TensorFlow record files and convert them into NumPy array, convert them into an example format, and then parse from example into a string, and then just parse the string. Okay. So some of you may be getting confused what this code is looking so complex. Don't worry about it. This is standard TensorFlow code. You can have this notebook after the end of the session, and then you can go through it, play with it, convert it as per your dataset. I would strongly recommend please use this for your dataset. Run something on top of it so that you understand what is happening inside TensorFlow extended. Okay, so you can see this is the insides of the TensorFlow record file. So these are the three records which came in. In total, I had close to 15,000, but I'm just preparing three records over here. So you can see the TensorFlow record file looks like this. First three records look like this. Drop of latitude, it is a float. Value is this one. Fare is a float. Value is this. Let me pick up this thing. Yeah, trip is integer. Value is this. Something like that, and so on and so forth. Okay, now we're going to move to the next component, statistics gen. What this component does is it takes the output of the previous step. So you can see statistics gen, it takes the output of the example gen component, which is my previous step, and then it runs on top of it. So what I'm going to do now is statistics gen. We'll wait for it to run and see what is the output. Okay, so output is again a new folder called as example statistics gen. So it would have created a new folder, statistics gen. See, this came in right now. Open it. Statistics folder number one. Earlier it created a folder number one, but now it has created a folder number two. Inside train, there is something called as a stats TFRecord file. Don't worry about it. We need not see what's happening. This is internal to TFX. It uses this file to detect drifts between two data set, or even detect the mean, median, max, and all those things about the data. We'll quickly see what are the statistics output over here. Yeah, this is a good part. I'll spend a minute over here. So I was talking about the part where TFDB is used to generate the stats. So this is the best part. See, right now, I don't need a specific separate library to build these plots and charts. I can actually see the distribution of my data set or the description about my data right over here. So let's say if this was petabytes of data, then you cannot do this in pandas. You cannot simply just run this thing that, hey, show me the mean for a petabyte data in pandas. But let's say if the data set is in petabytes, then you can do this using TensorFlow extended. It is made for this kind of scenario. So in shorthand, let's say if my data set was too huge, it would have run this step on Apache Beam or data flow or something, and then got these results. So you can see clearly drop of latitude feature has no missing values, mean is 41.9, zeros are none, max is so on and so forth, and then a lot of other attributes. So you can also see the distribution about your data set over here quickly. And then you can also have a look about your evaluation split. I'm not sure why this is not moving up, something related to my collab. That's fine. All right. So we have seen CSV gen, we have seen statistics gen. Now we want my TensorFlow extended to also be able to understand what is the schema of my data. Okay. So it generated the TFRecord file over here. Okay. It also generated the stats about my data. But what is the schema? Okay. So we'll run this step. So now the output of my previous step, that is the statistics gen, goes as the input of the next step, which is schema gen. I'll run it over here. Okay, and again a new folder called as schema gen would have got generated. Schema gen has got generated. I'm assuming folder number 3 this time. Yep, folder number 3. Again, two. So this is pbtxt. We can open this file, but right now I don't want to waste time on that. And we can see now what is the graph or plot. Do we have anything available? So this is the schema overall that my TensorFlow is detecting. So it says you have drop off latitude, longitude, fare. And what we're going to do in this problem statement is using these attributes minus the fare, we'll try to predict the fare. So fare will be my label, everything else will be my predictors. So we'll try to see if we can predict the fare. And this is the schema which it has come for this file. For these data set that TensorFlow Extended has detected. You can very well change the schema. I have not changed it over here, but it's not that you cannot change anything. You can go ahead and change the schema if you want to overwrite it with something. Um, you can explore more about TFX, rewrite the context schema gens output, and then let TensorFlow Extended use your schema rather than defining its own schema. All right. So this is a very important step. People usually ask me, Hassan, how do we identify that my model needs retraining or not? And this is a very important question in ML ops. So what happens is sometimes some businesses, what they do is they build one model. For example, let's say I want to build a model for cat versus dog. This model is never going to change. A dog will always look what it looks like today until unless a new dog, a new breed of dog, a new species of dog, or something like that comes up. That will always remain the same. And it's very easy to identify cats from dog. But let's say you are building a model for detecting of a model for recommending movies. Now that model will have to change within every week or every 2 weeks, or let's say even every day or an hour, as soon as new content comes up on my website or on my channel or something. So these kind of models, they need a continuous retraining. Okay. So what businesses they usually used to do so far is, some businesses what they did is they had their training pipeline or my machine learning model training code, and they used to set that every 5 weeks or every 2 weeks or every 5 days I'm going to retrain my model regardless of what is happening. Okay, that's one brute approach, wherein you are setting every 5 day rewrite my model or retrain my model. Now the risk over there is, so the con over there, let's talk about the good part first. The best part over there is that your model is constantly learning and learning a lot of good things. The bad part over there is, so let's say if there is a trend which is very spiked or which is very short and you trained a model on that. Let's say if it's Christmas right now and you trained your model right after Christmas trend, something like that, your model is very much prone or to the spike in that particular time season. Okay, but this is a good part. But let's say if you're in a constant season which is not changing right now, your model is not doing anything, your data is not changing, and you have constantly been retraining, you are then spending a lot of useless money, a lot of money you are wasting on the training infrastructure. So you're starting your Kubernetes cluster or your local Spark environment or something and wasting your money on that training which is not even required. Okay, so you need some kind of a mechanism, an automated mechanism, which can identify that whether your data has already, whether even your data has changed, or whether even the distribution of your data has changed, or something in your training data has changed, which requires retraining of the model. There, you have something called as data drifts management or data distributions detections. So there are techniques like, let's say, I am having a column which stores the colors of my product. And supposedly I'm launching a new color for my car or for my mobile phone. Then in that case, I need to retrain a model for that new color to recommend that color as well. Okay. So these kind of things, you can write code to detect new data set, new column, new feature, or let's say drift and all those things. But that will be very tricky for a normal human being to to understand all those kind of complex statistical concepts. Now, what example validator does is it has a lot of inbuilt things like it for numerical features. What it does is it tries to find distances between medians of the two data sets, like the current data set and the previous data set, median, mode, max. It has something called as the Shannon distance, which is the distance between uh, the medians or the modes of the two distributions. And there's a complex formula involved. I mean, I'm not an expert in that thing, but I can tell you it finds the difference between two data sets, and it understands, let's say, if the it will be able to understand if the latitude column has actually changed from a last training to this training, or the longitude column has changed, and it will trigger a alert saying that you need to retrain the model. The second thing is, let's say I had a categorical column, it had 10 categories earlier, and all of a sudden from last 2 weeks it has 12 or 13 categories. That definitely means we need to accommodate for that and do a retraining. So example validator is a component which does all that thing. Okay, so it can take all that, and it can also detect anomalies. Okay, so um, yeah, so let's say what it is saying. It is saying that a new folder has been created, which is called as example validator over here. All right, and these are the outputs. Okay, and anomalies, how it detects is it whether it uses the so it detects anomalies between number two things. It detects the anomalies inside a distribution, and it also detects the anomalies across two distributions. So let's say inside a distribution means inside my training data, is any column anomalistic? Is there a lot of skew, a lot of values moving outside some distribution, for example, using z-score or something like that? And across two distributions, that means eval and train. It tries to identify if there is a drift, the same thing which I talked about. Is there a statistical skew between the two data sets? Is there a drift, or all those sort of things? Now let's see what is the visual output. So it says that there is no anomalies found between both the data sets. So it's good to move forward with the training. All right. So quickly again, what I'm going to do next is, so I ran the same. So this is my same code from the earlier output. So example gen, I showed you 3 records. But this one I wrote in between to do a final show again that this is my final data that it looks like. So this is one record from my TFRecord example file. So drop of latitude, fare, pickup latitude, longitude, trip start, day, and hour and month. And we are going to use these all columns to train my model to predict the fare. All right. And now the next part is, now we're going to actually dive deeper into the main things. We're getting really deeper now. So this is a component wherein I would like to talk a little bit in detail how you can run this component and how I have chosen to run this component actually. So transform is a very important component. So before even going to transform, I would like to talk about Apache Beam. So Apache Beam is a framework by Apache, which stands for Apache Batch and Streaming. It is a data engineering component wherein you can write scalable data transformation pipelines. So you can write ETL pipelines either on Java or on Python. You can pull data from any source. That means you can pull it from BigQuery, files, CSV, Oracle, any database. You can collect it via JDBC, ODBC, let's say SAP, ERP, Oracle, Salesforce, anything. You can connect your data using this pipeline. You can write transformation rules both for batch data and streaming data. So you can write joins, window functions, calculations, and all those things. Same thing that you can do on Spark, you can do also on Apache Beam. Spark, on the other hand, also has machine learning capabilities, graph search capabilities, which are not there in Beam. Okay, so what is TensorFlow Transform? TensorFlow Transform is a library built by Google using TensorFlow and Apache Beam to transform your data using Apache Beam as the runner. You can use both Apache Beam, and you can also run transform code on your local environment. So even if you, let's say, don't have Beam on your local system, then you can still run that code. It's just that it will not scale up. It will take a lot of time for running. I mean, even if you have a lot of, even if you have a huge file, let's say 1 GB or 1 TB, it will be able to manage it to run this on your local system with the TFT code. But when you are going to do that for a larger file, you would definitely want a number of clusters to be able to do that quickly. Okay, and some of my friends on this session would definitely be knowing a lot about Apache Beam. But what you can do using TensorFlow transformers, you can write code in TensorFlow that can do transformations using TensorFlow transform. So let's say I want to add a new attribute called as distance by using my latitude and longitude. I can write that thing over here. But since in Collab we don't have the option of running TensorFlow transform on Apache Beam, what I've done is I have written code in pandas to create my TensorFlow, to create a replica of what's happening in TensorFlow transform. So what I wanted to do is actually I wanted to create two new columns, bins lat and bins longitude. And what these actually are, these are the binnings of latitudes and longitudes. And I would not talk in detail why we are doing binning of latitude and longitude. Again, you can go back to my AI engineering first session, wherein we have talked about the taxi data set over there. In depth, I've talked about what is binning and why have we done binning on drop of latitude and longitude. But just to give a gist, since these are both GIS or global latitude longitude information, the best way of representing latitude and longitude is not by a numerical or categorical attribute, but by binning them into multiple bins and then doing a cross cat on top of it. So you'll create categories of bins, categories of latitude, bins of latitude, bins of longitude, and then you'll cross over them so that they create grids. And you can then say that every location is one bin and one bin of latitude and one bin of longitude. So that is how we'll represent every location on the map. Okay. So what I'm going to do next is I'm going to create bins using pdqcut, and then I'm going to write this whole code in one file. Okay. So right now, what I'm going to do is I'm going to close this folder, and as soon as I write this file, it's going to create a new constants file over here. See, it created constants trainer.py. And what I've written over there is I've just written these two things over here. So what I'll just quickly open this file, how it looks like. So this file which has been written looks like this. So I've just written the constants of my file of my data in this file, and I can use these constants directly because they're now exported as a Python file. So that's the best way of using constants directly. So I can keep on writing as many constants that I want directly using a dynamic way. Okay. Now what I'm going to do next is the interesting part again. I'm going to create a training code. And I'm not going to just create a training code, or I'm not just going to run it. I'm going to write that code again in a file. So I'm going to create multiple files. This was my constant file. Then I'm also going to create a trainer file. And all these files will then be sent to my trainer component. So the training file, constant file, and all, they will go to my trainer component on TFX, which will pick up all these files and run my training on my training dataset. Okay, quickly. So before going in the cell, what it does is this component does not let the code run in this piece. It just picks it. It makes sure that the write file component in Collab, it picks up this whole content all the way in this cell and writes it in this file. Okay. So again, I'm going to show you. Right now I have only one file, Python file over here. And what I'm going to do is I have created some functions, like I have created a feature engineering function. I am going to do a feature engineering inside my model. Okay. Then I have created a make input function. So this is some code which I have written to pick up the TFRecord files in the TFX folder. So I've mentioned that wherever my file is mentioned, I'm going to pick up that file, read all the attributes. Okay. And on top of that attribute, I'm going to apply feature engineering. So all these attributes have drop of latitude, longitude, but I also want to apply feature engineering on top of them. Okay, what I'm doing in feature engineering is I'm creating a new attribute called as distance, which is going to compute distance or Euclidean distance using latitude and longitude. And it is also going to convert the data type of three of my attributes, month, hour, and day, from integer to string. Because if you remember, I showed you when I was showing the TFRecord file earlier, all these attributes were int64, but I want them to be taken as categorical. So I want them to be converted into string. So this is the feature engineering. Okay, and there may be questions around it. We'll take all the questions at the end of the session. Whatever you have, you can write it on the chat. We'll take all questions. We'll put ample amount of time on discussing those concepts. Some of these things can be complex because I know TensorFlow is quite difficult for a lot of people, but that is what we are here for. We want to make this easier for people to understand TensorFlow and make them understand and realize that TensorFlow is actually very helpful for making end-to-end enterprise pipelines. All right, so what I'm doing here is input function. I'll explain this function. What I'm saying is pick up all the files in directory. So what this is going to do is I am going to pass directory URI as the output of the CSV example gen. So I'm going to say pass the directory as the full directory for training this part. From there, it will read all the TensorFlow file, sorry, all the TF-record files. I'm sorry. It is going to apply batch function. Again, all these features all these options I've explained in my previous session. You can go over there. But quickly telling you batch, what does is it will read batch size number of records from the TF record file. So let's say you want to read 32 records or 50 records or 120 records. It will read only these records. So if my file is really huge, let's say petabytes, this code will never fail. It will just read those number of records. After that, it will convert these records which it has read into. I want to do some kind of a decoding. So decoding means I want to convert these features into my columns basically. So I've created a function called as decode underscore TFR, which is over here. So every record from the TF record file is going into a parser over here. It is converting my TF record file into a parser, into a dictionary over here. Okay. And on top of these dictionary columns, I am then going to apply my feature engineering function. So which is over here, which I just explained. Okay. Then I'm saying if this function is running in train mode, then the number of epochs are the epochs which I'm passed in the function directory, or it will be 1 if it is running in prediction or evaluation mode. Okay, then the same number of code, I just want to repeat this by number of epochs. I'll run this function and it will create a new file. Let's just wait. Yeah, I'll quickly show you what it has done. So all my trainer code, which is over here, it has simply just exported this code. It has not run anything. It has exported this code inside this file. All right, now what I'm going to do is, so this is the name of my function trainer. Now I want to test. Okay, I mean, I cannot just create this code. I also want to make sure that the whole this whole input function which I've created over here, is it even running, or I've just joked, or I've just done something, some kind of an error or something. Okay, so what I'm going to do is I'm going to import this file as IFT, and since in IFT I created this function called as make input function. So I'm saying make input function, call this, and I created an eval file variable which was example gen outputs, which we got. I also showed you from above, and here I've said train, but you can also call it as eval. So it is going to, so this variable over here is pointing to my train directory inside my examples folder over here, which is I think this one. Yeah. So the same which I showed you. What I'm telling is pick up all the TF records file from my example train folder. I mean, I can also call it as eval. Let me call it as eval only. Okay. And I'm saying read just 10 records from it. So this is how I'm going to test my function over here. I run it. And voila, over here, it converted my TF record file into my TF dataset output. So these are the outputs which we usually get from my TF dataset function. If I was running this directly on my CSV file, and I can then pass this data as it is into my TensorFlow model or Keras model, anything that I build to train the model. Okay, and I'll also show you. I think it has also created the distance attribute over here. See, it has also created my new feature engineering attribute, which is distance, and trip start date, hour and month. Earlier they were all integer, now they're all string. Okay, so my feature engineering is also working perfectly fine. Now next thing is, so right now I have constants trainer, input function trainer. So these are my two trainer attributes. So I needed constants, I needed input function. Okay, now what I need to use is I need to write my trainer code as well, the main code wherein I'm going to create my model and do the whole training and everything. Okay, so here I'm going to use a strategy resolver. TensorFlow has an option wherein you can specify a strategy whether you want to run your code on TPU or GPUs or even on CPUs. So for that, I've created my code over here. I've said that if, and this is a simple code, you can just directly copy paste it in your any code in Python, any TensorFlow model. You can wrap it up in that. I've given some basic parameters for learning rate beta 1, beta 2. You can also search them using hyperparameter search. TensorFlow Extended also has a component called as tuner, wherein you can just set it up and it will find the best hyperparameters for a model. I have specified feature columns, so I have columns like month, hour, day, pick, lat, longitude, latitude, and distance, which are my input for the model. Okay, and I've clearly specified that month, hour, day are string. Everything else is float. Okay, this is how we actually create a Keras model. After in that code, and again, this is not going to run. It's going to just export this whole code inside my trainer file. I'll show you. Then in the model code, what I've done is I've done a lot of created a lot of features inside. Again, I won't be spending time here. There's a separate session which we have already talked about. I mean, same session wherein you can go ahead and watch that. Why? What is the meaning of all these components? So TensorFlow came up with new experimental features wherein you can create one hot encoding, category crossing, and everything bucketing inside your model. And I actually prefer doing that inside my model because that makes a model agnostic to any kind of environment. So if you're doing feature engineering inside your model, you don't have to wrap the feature engineering step outside your model. You'll just have to pass all the basic data that you have available, and inside the model can calculate all the feature engineering and pass it to the model. So I'm doing all those things over here. But one thing which I wanted to show you is I've also imported my constants file over here. Constants trainer as CT. So I've imported my input function trainer. So if you see over here, I've imported my this file and constant trainer as well. And how I'm using it inside this one, I'll just show you. That's very important. So yeah, let me just where did the CD thing go? Yeah, bin slat. Okay, create Keras model, bin slat. All right, so I've created the whole code over here, and I'll quickly show you how I've used them. Create, yeah. So over here, yeah, sorry. So I've concatenated all the columns. I've concatenated, and this is how I am creating a deep and wide model. Um, concatenated both the outputs, created the final column. So this is a regression model. We want to predict the fare. We want to use a ReLU kind of activation. Then we want to have some hidden layers. I've chosen how many hidden layers I want. I can choose it. I have set that as a parameter on top over here. Hidden layers is one only. And when I run this whole code, I've also created a method which says Keras train and evaluate. So this is the function which will train my main code. So it calls the model as an input to it, wherein I've specified the validation data set, the training data set, which are again are going as input to this function. I've written a save model function again inside my whole trainer file, wherein I've added the feature engineering function plus the payload and everything. And after that, so this is one important function, run underscore fn. So your training file should have the run underscore fn function. Okay, this is the, and you should have done the function with the same name inside the file. Once you have that function, the TFX will pick up this function, pass all the arguments into this function, and run this whole code. Okay, now I want to show you the IFT and CT which I was talking. So if you see here, everything which I'm referring across my codes, I'm not just picking up the code from previous cell and calling it over here. Okay, I am making sure that my files are communicating via imports. Okay, so if I have to use the code from input fn trainer, I'm not just picking up what is there in memory right now in my collab session. I'm importing it first and then using it, because my whole TensorFlow pipeline will not run in collab. It will run either on clusters, or it will run on Kubeflow, or it will run on Airflow, or even in local. There it will not have this whole interactive environment. Some things may be running in parallel. They may not have references of each other's. One cluster may not have reference of others' memory. That's why we need to make sure that everything that we're using across, it should be imported as functions and files. Okay, so if I'm using my train dataset, I'm saying ift.make input and then train files. Validated dataset is ift.input and then fnargs train files, fnargs eval files. Okay, then I'm calling the create Keras model function over here. Create Keras model is something which I defined on here. Okay, so I'm creating my Keras model over here. This is m underscore. Then I am also going to show how my model looks like, and then I'm calling the Keras train and evaluate function, which I created above, passing the train dataset, validation dataset, and in the create Keras model, see, I also pass bins lat and bins lon as my attributes. So all those distributions, all those constants which I've used over here, I can pass them as arguments to my functions over here. Okay, so I'm just giving you an idea. Right now, it will look complex in whole, but when you go back and you read this whole data, this whole notebook, you will be able to relate things, and you should go on it one by one. It also took me a lot of time. It's not easy for me as well. It was not easy at all. So definitely don't worry if you're finding it a little bit difficult to understand right now. We'll go through all the questions and everything. We'll take a high level understanding, and you'll have to explore what's happening in the notebook. All right, so I'm calling my train and evaluate function. I'm passing the model, the train data set, the validation data set, and I've also created something called as epochs. So I want my epochs thing to be passed from outside. Okay, and then at the end, I'm saying when the model gets trained, I want to call my save model function. Now, save model function over here slightly looks different, and I want to spend 1 minute of that. So you saw that there were some things which I did outside the model. So I created the distance function. I created a distance outside my model in the feature engineering step when I was reading the data, but I did not write the function for distance calculation inside my model anywhere. I did not write it anywhere over here. Okay, it is an input to my model because I've said that it is a feature to my model. Now, if you remember, distance was not there in my file. Okay, I'm getting only these attributes. So how do I pass distance when I'll serve the model? My model is expecting distance as well. How do I send my distance as an input? I won't expect my user to pass distance also. He will only pass these 7 attributes, but I want to pass distance as well to my model. So that is called as a custom routine for my model serving. So any TensorFlow model that you build, you can also wrap a custom routine. Okay, and this is how you do it in TensorFlow. You create a serving function. Okay, and herein I'm saying distance is drop of latitude and this whole formula, and then I'm passing it over here and calling my model function, and then I'm saving my model over here. So this is a standard notation. Don't get confused or don't worry about how I did come up with all these things. There's a lot of googling and everything. And after a lot of hit and tries, I came up with this whole function. So you can add new features inside your serving function. You can create new features inside your serving function, and you can then save the model. Okay, so this whole sort of all sort of laborious work is going inside this file. What I'm going to do is let's see how my file looks like. So this is my trainer code. So in the end, I have 3 files: constants, input function, and model. Constants is where I saved my constants that I want to use inside my training code. Input function, which is going to use which is the function which is going to read my data set, or read my TFRecord files, do feature engineering on top of it, and then pass to model. Okay, and model is my main code where I'm going to do the creation of the model, the training of the model, and also the saving of the model. So creation, training, and saving is all done in the model function trainer. There's no hard and fast that you need these 3 files. You can have the same file at the end. You can just have just one file in the end, and you can run training on top of it. Now what I'm going to do next is, so a lot of things happened over there. Now I want my trainer component to get called. So trainer is again a standard TFX component. It takes the module file, which is my trainer file. Okay, and then I'm setting that this should execute in my local. Okay, if you're running this on AWS or GCP, you just have to change this thing to specify SageMaker or AI platform, and it will just run. The best part about TFX is you don't have to change the full code to run it on AWS, Azure, or GCP. You just have to change some parts of it, and this whole thing like just modifies itself to run it on any platform. And if you don't have any platform, you can just deploy the Kubernetes cluster on your cloud platform and just deploy it and run it over there. So it's such easy thing to do with TFX. Now what I'm specifying is examples. Examples mean this code should pick up my file, should pick up my data from example gen.output. Okay, but here I've specified train files over there. Okay, so train file is again coming from this component over here, fn args. So it says train files and eval files. Now, so anything which I pass over here as train args and eval args, sorry, examples over here, TensorFlow extended makes sure that those things are automatically converted and passed as inputs to run function train files and eval files. Okay, so that is something automatically done inside. Again, so I wanted some custom configuration attributes also to be passed. So epochs is something which I created custom, and you can see I passed it inside over here, fn args custom configs epochs. Okay, you can create your own n number of custom components, custom attributes, and you can pass them. So currently I'm just going to run it for one epoch because right now I just want to show you interactively how it looks, and then we'll spend after when we'll be taking questions, I'll run it for 50 epochs and I'll show you how this whole thing runs. So right now my training code is running. This is my whole model. So there are all these input features and applying all these transformations on top of it. There are 14,000 attributes that are there, and then this whole training code is running right now. In one epoch it is giving me RMSE as 16, but we'll run it on top of it. And again, at the end of the whole run, the outputs are two things: model artifact and the model run artifact. So you'll see the new folder would have got created. Let me open TFX. I think trainer came in over there. Yeah, see, trainer came in. Trainer created two more things: model and model run. So I think model would have called my saved, saved model, and yeah, see, it saved my saved model over here on top of it, and this is my saved model. I can use it, but we're not going to use it right now. We'll hold on for a minute. Okay, we can also do the TensorFlow monitoring. I'm not going to run it because my training has stopped. We can do the same thing using TensorBoard over here. We can just specify what is the output of the training model function, and we can run TensorBoard on top of it. Now the next component is pusher. So pusher, what it does is it runs basic check whether your model is serving properly. Is it in a servable condition? Does it have any errors, syntax errors, and anything of that sort? If it does not have, then it just simply saves your model. Okay, this component can make sure whether you want to save the model as a TFJS file, light model, or the model on GCP AI platform or AWS SageMaker, or in local. So you can choose any of that thing over here by changing the serving model directory, and it will automatically save it in that format. Okay. So what it has done is it would have created a directory again called as pusher. Okay. So I'll again open TFX. It will show pusher now. Yeah. See, pusher is over here. Pushed model. So this is the final model, and it has the saved model PB. So even though my output from the model trainer over here was also a model, but what it does is pusher runs some internal sanity checks and make sure only after that you're getting your output from push model. Okay, and we're almost there now. We can see the output from pusher outputs, and we can also, these are the output of my model. So it says that, yeah, these are all the things, date and everything, signature outputs that are there. All right, and these are all my outputs. It says that these are all my input parameters that are required. Now, in reality, the pipeline that we have run, okay, that I've showed you so far, I've showed you in an interactive way, okay, but in reality, this pipeline does not run interactive. You would either want this to run in local without these whole set of logics, or you generating Python files and all. But in real, what will happen is we'll want this whole thing to run either on Airflow or Kubeflow or in local or on some of your internal Kubernetes environment. So what I'm going to do next is I am simply going to clear this whole directory. Okay, I'm going to delete my Python files. I'm going to delete my CSV file. I'm going to delete all the data files. And what I'm going to do, what I'm going to show you is how we can run this whole pipeline in a single function. Okay, so step by step, I'm going to first clear my whole directory and just download the data file again. Okay, so everything is gone. My model file is gone. Only eval data is left, and TFX is completely empty now. TFX is again what we had in earlier. Okay, again I'm going to just create two files now. I'm going to create train data and eval data. Okay, I'll just quickly run this code. Okay, so in eval data, I would have one file, eval.csv. In train data, I have eval.indata.csv. And what I'm going to do next is I have taken my, so the all the components that I created above, examples in CSV Gen, I am just going to promote them and put them step by step over here. So first I'm going to call CSV Gen. CSV Gen's output goes to statistics Gen, then schema Gen, then example, trainer, pusher, and everything over here. Okay. And you, if you see over here, I'm just going to run it. All right. Where did this thing go? Yeah. Okay. And what I'm going to specify here is I am going to call my pipeline. So I can run my pipeline in local or on Airflow or anything. I can just change this code. I mean, it's very easy. If I want to run this on Kubeflow, I'll just have to give the Kubeflow directory, Kubeflow URL, and all those required things. And what I'm going to do now is I'm saying that my TFX path, root path is TFX, which is again over here. I want to run my model for 50 epochs. And this is my final code. So create final pipeline code is over here. It's going to run over here. And on top of it, I'm just saying run. So I'm just passing the data path, pipeline name, and training parameters. That's it. So this is exact. This is in real. My pipeline will just run in 5 lines of code over here. Okay, and that's done. So we'll let it start now. We'll let it run for 50 epochs, and we'll open up the session for questions while this thing runs.
Sure, Asanam. I know it's too much of information. The TensorFlow pipelines are created that way. Uh,
Right.
but but if you really see, like, when you want to get your model run end to end, right? Not only the ML code alone. Like if you
Hmm.
want the data handling to data processing to feature engineering, to final deployment, right? You're going to show the deployment next. So this pipeline really makes it easy and reproducible. That's the main advantage of it that I have seen. But Asan, I have a question to begin with for you, right?
Hmm.
Can we use any other tool like scikit-learn or something in the TFX pipeline, or is it more specific to only the TensorFlow part of it?
As far as I know, Shri, I think for now we can only use TensorFlow. But I think there is some alpha work in happening in for PyTorch or Cafe, which is happening inside TFX. I mean, I just heard it somewhere.
Got
But
it.
right now in public release, it's only TFX, TensorFlow. I'm sorry.
Got it. Got it. So kind of it's kind of like becoming the ecosystem is also becoming crowded. Like if I have to use
Correct.
TensorFlow, maybe TFX is an option. But if I'm using like scikit-learn or some
Correct.
other aspect of it, then I have some custom MLOps cycle built in.
Huh.
Mm,
Huh. And on those lines, I think what we can use is, so I personally prefer Airflow as a tool to build pipeline because I'm very well versed with Airflow, its environment, its IDE, and all those things. And I think someone posted on the group as well that can we use MLflow and how MLflow is compared to TFX. So MLflow is actually an orchestrator. MLflow is comparable to Kubeflow. MLflow is not comparable to TFX. TFX is like a code which sits on top of Kubeflow. Okay, in Kubeflow you can write your own code which you can write components to run pipeline, but you can assume TFX is that whole environment wherein you don't have to create those components. It is built as an MLOps framework for TensorFlow. Okay, because I know a lot of people, they don't explore TensorFlow a lot. People are usually scared. Even I am very scared of using TensorFlow because of its complexities, but now it has actually become very friendly. I mean, I won't say as friendly as other frameworks, but it's still very friendly compared to its previous releases. So it's getting better adoptable, and with TFX, I think the adaptability is only bound to increase. So you can build pipelines on TFX and run it on top of Kubeflow. Let's say MLflow, I would say, is a slightly different environment. I have never tried TensorFlow on top of MLflow, but it's seeing its capabilities not as matured as what we get on Kubeflow, for example.
So ML flow is actually like a very subset of your MLOps cycle, right? If you want
Right.
your project or if you want your model tracking, right? If you want your
Hmm.
experiment tracking. So when you talk about Qflow has one component for experiment tracking, and ML flow can be that component. So ML flow
Correct.
fits in very well with your Qflow pipeline or other pipeline as well. Um,
Right.
So that way it really helps. There's a question from Rohit. Okay, let's start with that, and I will go to the other question as well. So Rohit says, "Hello, Ashan. You just mentioned that the distance field will get created on the fly, and the formula for that will be captured with model frozen. So
Right.
during the serving, when we get raw data that time, the model serving will also have distance creation formula will automatically create. Is my understanding correct?"
That's correct, Rohit. That's correct. That's the
So
part. I mean, and it's a very good question, actually, Shri. So, usually people in TensorFlow, we don't know a lot of things, a lot of hidden capabilities that come in with TensorFlow. So this function which I've created, Rohit, on top, it actually does the same thing which you're doing. So which you're asking. So this line gets recorded as frozen on the model. So if you see, distance function gets called over here, and then I'm passing my serving function in this whole thing, and it gets saved on my model over here. It gets recorded in my frozen graph. I'll also show you the inference. So we'll let the model train for 50 epochs, and when we'll be doing inferencing, I'll show you how we only pass the non-distance attributes, and then in the end, my model can calculate distance and do the inferencing on top of it.
got it. And I think it's
Yeah,
a follow-up question from Rohit. He just summarized. Yes. So based on what Asan said, Rohit, right? Whatever you do during your training, everything is captured in your serving infrastructure as well.
yeah,
So there's one question from MP Lakshman. Which one is good, like ML flow, Q flow, R flow? So these are all like
yeah,
different tools for different. I would not say different. For see, Airflow is more like general open source framework for orchestration. You can orchestrate anything with Airflow. Uh, it is pretty straightforward, pretty simple. You can write your own like Airflow connectors as well and connect it. But if you take like Qflow, go ahead, Carson. Like, what is your thought on Qflow when it comes to
yeah.
orchestration compared to Airflow?
Yeah, I think see, you already covered it up. So first of all, I mean, if I talk about Qflow and Airflow, so Qflow is difficult. I won't be hesitant to say it, but Qflow is difficult because it runs on Kubernetes, and Kubernetes is not easy for everyone. At least for myself, I think that Kubernetes is not very easy when we're doing it for the first time. And with Kubeflow, since it is all new, you have to be very familiar with what it is doing. So there's a steep learning curve with Kubeflow. That's number one. Second thing with Airflow, it's more like Pythonic. You can build Pythonic kind of code on Cube Airflow and build those pipelines. You can actually see it. It's easy to debug, easy to run, easy to scale. Kubeflow, on the other hand, wins on the things like it is very ML specific. So if you want to track experimentations, if you want to see the results of every experimentation, if you want to switch to code of a last ML experiment, all those ML specific things we can do on Kubeflow, which are not possible on Airflow. I mean, so it's more like ML flow is for MLOps.
Right. And frankly, like I have been like trying to set up Kubeflow pipeline. I gave up initially last year. In fact, like my experience with Kubernetes is pretty vast. I have been working in Kubernetes for so long for deploying models. But when it comes to
Hmm.
Kubeflow, the way they have architected it, and Google's knowing Google how they complicate things, take it as a more engineering approach rather than like a end user approach, right? Qflow is difficult, but I think it's getting better. They are also adding a lot of features,
Hmm.
making it more friendly. So we will see a better Qflow maybe sometime soon.
Someday,
Yeah.
someday, actually.
Yeah. So this is a question from Thiru. How does TFX serving work? Is it TF serving only?
Yeah, it is same as TF serving only, they do nothing different.
It is like some of the components they moved into TFX and TF serving is almost same. And I think like you have the next one right after the training is complete. We will see that as well. Uh,
Right.
there's a question from Ravi. Please, could you explain what will be the next step when there's a data drift and the model needs to retrain again in production environment?
Should you want to take that, or should I?
Yeah, I can start with it. So,
Okay.
see what happens like now you have the statistics, right? You have the statistics gen where you have collected the statistics, and there's one component which we are not covering today. Are you covering model analysis?
No, model analysis is not it. Yeah.
So
TFMA we've not.
okay. So we have model analysis, and we also have what if tools where you can find model drift, and based on the statistics that are collected, you know if there's a data drift in any environment. So you can set your threshold simply on when you want to call a data drift, because sometimes it's pretty natural the data distribution to change over time. But if there's a significant change, you can set a threshold that okay, I want to go and retrain my model. And if you see any data drift, you can trigger off your Airflow or Kubeflow pipeline again for the model training, and you can take that model, and maybe you want to add on the model analysis tool, Asan, right? How that can help
Correct.
you have a new model. Go ahead and add.
Correct.
Yeah.
Correct. I mean, TFMA is really good. I saw this on one of the Coursera sessions. I mean, but I was not able to set it up. I probably have to debug a little bit on TFMA, and I'm inviting if someone knows how to set up TFMA on custom saved model. I'm more than happy. You can reach out and maybe we can work out something. And maybe next session we can show TFMA and what if tool, Jenny.
Yeah.
So
Yeah, so we can do that. So TFMA is basically like you're comparing multiple models. You're kind of doing an A/B testing of your model. You can then see like whether your new model is performing better with live data, and you can switch it. If not TFMA also, right? You can just run simple population stability index statistics across the two model output distribution, and then determine whether the model is drifted. The data drift is pretty straightforward. But model drift is you can run simple PSI or KS stats and see if the data is drifted, and you can re-trigger the pipeline. That's what we
correct.
typically do, Ravi. Now, this is an interesting question for which it's from Thiru. How does data drift work for NLP and CV?
Oh my. I think this is something which I need to take a break for like 15 seconds and think over. Or you want to go ahead and take a shot, see on that.
Yeah, so I still rely on model drift when it see basically depending on how your NLP model is. If your NLP model is working on simple TF-IDF or something like that, right? You exactly know what are the top features you selected, and you can check if your data in that features is similar to how your training data or how your historical data is. It's kind of I would not say simple, but kind of at least possible. But when you're going with this black box models and all, I don't have an answer for it, frankly, and
Right.
uh, I would
So,
kind of
what I can say about it is, if I would have to give a very intelligent answer, maybe over-engineered, but what I can say is you can probably combine something with an auto-encoder. Okay. So you can, let's say, build an auto-encoder, which you also train on your current data set. Okay. Let's say if you have an auto-encoder that tries to reconstruct your next data, then you can use reconstruction loss probably to understand whether your NLP or CV data is drifting or not. And I think that's the best approach which you can follow. And I can think of it only that right now, because autoencoder is something which is being used in a lot of the places to understand anomalies for image data, for NLP data, time series data, and it's mostly automatic. So that kind of a data and that kind of an information or a solution that I can give you. Maybe you can think over about something else, but that's my answer to it.
got it. And model drift anyway works similarly, like whether it's an NLP model or a CV model, because finally what you're trying to do is you're trying to check your model distribution and find if there's a drift or not. So that will
Right.
be pretty straightforward. But the data drift is, as you said, it can be autoencoders, or if it is a TF-IDF model, where you are picking the maximum, the top 10,000 categories, we can monitor it and see if it's falling in that category or it is moving to the next 10,000. So
Hmm.
those are some techniques, but Thiru, like there is no concrete answer or generic answer similar that you ask for structured data. Maybe it's very use case specific. That's what we handle it.
Right.
The next question is from Maunik. My question is, how should one go? One should be with TensorFlow to get started with TensorFlow extended. Good, Asan.
Yeah, I think this is one question, Sri, which we keep on getting in. So I would say, see, I'll tell you, I am not a very much expertised person in TensorFlow. What I usually do is I just pick up one problem statement in TensorFlow and I try to explore it as much as I can. So these notebooks, which I usually present, what I do is I just pick up one data set and you have to explore different ways of building that thing. So right now, for let's say for on my end, what I'm doing right now is I'm trying to plug in more components in TFX, make it a little bit more robust and modularized, and maybe I can then explore it and make it easier for others to understand. That is how you want to explore TensorFlow. You don't have to be an expert in TensorFlow to get started with TensorFlow Extended. I would say pick up a very simple dataset like Iris or the Titanic dataset. First, build a TensorFlow only pipeline, okay, and then try to incorporate that in my TFX notebook. So you have my code from the previous session and also from this session. Try to change it from as per your dataset and then plug it in. That is the best way you can start with TFX.
Got it. And I'm going to attach the link of the previous video. I am missing
Yeah,
the previous video here. I will do that with this video as well, so that you can check how the code looked like without TFX pipeline and how it looks like with TFX
correct.
pipeline. Right. So there's a message from Ram. Like Hasan, this is one of the best tutorials I have seen on TFX. You have taken modelization to a completely different level. Congratulations. And it was really insightful session, Hasan.
Thank you.
Right, as
Thank
Ram
you.
is saying, it's like to break up the different components of TFX and show each and everything. It was like an amazing work that you have done. And thank you, Ram, always for your
Thanks,
support.
Ram.
Yeah.
Thanks, Ram. Yeah.
I think the training is done. You want to complete the serving and then we will go
Yeah,
to
yeah, absolutely, absolutely.
yeah.
So training is done, and what we'll quickly do is two steps. And I think someone asked that question, probably Rohit. So what we'll do is now we'll see how the SAID model looks like. So since we had clearly completely closed the and cleared all the folders over here, we'll now quickly go back and see what has actually happened inside TFX. So when TFX ran again, it again created all these files inside. So it created pusher, example validator, and all those things. Now what I'm going to do next is I'm going to open the pusher, which was my final component, and going to see what has happened. So inside 4, it created my SateModel.pb file, which we were expecting to also have the frozen code for the distance attribute. Okay. Now if you see over here, in the model's input, it only shows latitude, longitude, attitude, longitude, pickup, drop off, trip start, day, or month. Okay, and it predicts the output, which is -1. I mean, output as the fare. Now you won't see the frozen code over here, but what I'll do now is I'm going to run this whole code. What I've done is I've taken a sample data wherein I'm going to load my model again from this directory. This is the standard code to load a saved model. Okay, and what I'm going to do next is I'm going to run these 7 attributes: drop off, latitude, longitude, and you cannot see distance is not here. Distance I have not passed in. Okay, but if I run it, it will not give any error of distance. Okay, that you have not passed distance or you have not done this thing, and see it has given my fare. Okay, now I'll also show you a negative testing. So let's say, what if I don't pass a required mandatory attribute? What happens? Okay, it should give an error that you missed out this attribute or not. Okay, so it says that no, it gave me an error missing drop of latitude, longitude. So I'm going to put it back and call it over here. So it actually means that I passed all the required attribute, even distance was passed, and the fare was correctly calculated over here. So this marks that even my distance function that was there has been put in the saved model. Now this model is as good as you deploying it on any platform. You can deploy it on AI platform, AWS, SageMaker. You can put it on Raspberry Pi. You can put it on mobile phone. Anything that you want to do it. Now your old TFX end-to-end pipeline is ready. You can just deploy this whole code anywhere. That marks the end of this whole thing. We had other things planned, but maybe for next time.
Yeah. Great. Let me see, like, what are the other questions? Again, like Devashi just mentioned, thank you, Asan. The session was very informative and practical. Okay, Thiru has rephrased. I will rephrase data drift of NLP and CV in TFX. You have any insight into this, Asan? It is generally in TFX. I'm not sure. I just seen TFX for structured data.
Correct.
Yeah.
Correct. So one thing, Thiru, that we can do is, and I am sorry I missed that part. So TFX not only requires you to use these standard components, you can also build your custom components. I have not tried it, but I will try it how we can build custom components. So you can write your own component. So let's say if you want to build a custom component that wants to detect using this autoencoder or some other approach which Shri mentioned, we can build a custom component plug it in our pipeline, save it as a Python code, and use it on the cluster. So we can do that thing as well.
I think it's again to do like there is some process going in TensorFlow data validation for NLP but didn't get how exactly we can use it on in TFX. Thiru, I am also not sure. Maybe maybe you brought an interesting point. It's we will go back and check it out today. I
Correct.
have covered TFDV in detail in couple of videos. Which is there are separate videos you can find on my channel on TensorFlow data validation. It was more on structured data. Maybe recently they added NLP and CV. I'm not sure. I also need to go and check it out.
Yeah.
Please share. Yeah, the collab notebook will be shared. You can see it in the video description after this video is live. So you can see it over there. So Rohit is telling for CV, can we do data drift by comparing the distribution of feature map of training data and serving data? So when you say feature map, you're telling like the byte array of the image data or something like that, Rohit. If uh,
I would say you can do it to some extent. Let's say you want to build a k-means model on top of it, and you want to do something as can be done. But I think there would be definitely some best practice around detecting drifts in CV and NLP, which we may can find out. What we can do is we can post a comment after the session after doing some analysis. I can at least look for it, and also Shri can look at it, and we can add information. I think this is a good topic to be brought in. We can definitely train NLP and CV models, but how do we implement those things?
Right. Right. I'm not like that big of an expert in the CV side of it, but we have some NLP pipelines running in production. I mean, typically stick on to model drift, right? We don't go into the data drift aspect of it. But we also know that when we are serving, if the top categories that were there in my training set or in my final set is not there in my serving set, I exactly know my model is just doing a default prediction because it is not able to find the TF-IDF vector of any of the incoming records. So that also we monitor. Okay, but maybe, yeah, Rohit, we also need to do some research, and it's a good weekend work we have got to do. Yeah. Yeah. So when we flatten feature map before we send it to fully connect, got it. Okay, that's a good question, right? So you have a flattened map. Maybe
So he's saying,
I need to go
yeah,
and research, right? Maybe
correct.
what is the after the convolution is done, you have flattened map, right? Maybe on that, quite possible. Maybe yeah, maybe we're not able to immediately think. Maybe we can go and check it out if there is. Mm,
I mean, just to give an idea, Rohit, what you can do is the way we detect um, anomalies anywhere, anomalies in any kind of a black box model is using either an autoencoder kind of a technique, or let's say the same thing which you said, that we can use it as a dense feature mapping and all those things. We can find that thing. But I think best is we will find out some kind of a paper or something that would be there, how it is being done, and we can then probably come up with something like that.
Right, and I like that idea of autoencoder on the flattened feature map, right? Because once you have the flattened feature map, you train the flattened feature map with the autoencoder for the known data set, right? If any unknown data set is
Correct.
going to come, the reconstruction loss is going to be higher. So
Higher.
maybe that seems to be a good idea as well, Rohit, right? Use an autoencoder and then see if there is a higher reconstruction loss, then go and do further analysis on that particular image or something like that. Mm. So again, great simplified tutorial session, Hasan. Kudos to you. And I think like that. So there is one final thing. Ranjit is asking, can you please tell me the difference of TFX Airflow based versus new data update model, rapid in Flask,
Okay.
fast API, containerize, redeploy on server or AWS Fargate method? Okay. So you're asking like a plain vanilla MLOps pipeline versus
Correct.
TFX MLOps pipeline. Uh,
Correct.
like, yeah, so Ranjit, the previous session, like we covered that as well. Now you can build your own continuous integration, continuous deployment, continuous training pipeline. And in a lot of cases, it works better as well, I would say, because TFX is only for TensorFlow. Now, if you have like using 5 or 6 modeling tool, you don't want multiple MLOps pipeline. Maybe you want to have your own customized MLOps pipeline. You do a Git check-in, it creates a Jenkins job, it containerizes it, and then it redeploys. You can build that on your own as well. Now, but if you have a lot of TFX job to maintain or a lot of TensorFlow jobs in your organization, then maybe TFX simplifies it, right? If you set some guideline or process, what do you think, Asan, on that?
Yeah, yeah, absolutely. See, the best part with TFX is, I think it's an industrialized method. I mean, Google uses TFX, as far as I know, and as far as I've seen in some of their papers. Google uses TFX, and they are using it. I think, not being inclined, but no one is using machine learning as much as Google is. So it's YouTube, it's Google Maps, it's everything that is around, even on our mobile phones and everything. And trusting a framework rather than building our own is something that means that there is something already handled inside that framework. Okay. Now the difficulty with TFX is definitely there is a steep learning curve involved. But with TFX, what we can assume is, since we are going to use TFX, a lot of things that we are not expecting in our custom solution would already be handled there. Okay, and it is constantly supported by the open source community, plus being improvised by Google again and again. So that's the difference. Moreover, it's like you can start with an Airflow based solution. Definitely, I also prefer doing that. But if you have to operationalize something using a CI/CD pipeline, so there are a lot of things also which we did not cover up. Tuner component, a data pull component. It will be difficult if you want to start building that whole data engineering pipeline as well on Airflow. So it's quite eased over here
Got it.
with
My,
TFX.
my,
Yeah,
my part was more like, see, when we in an organization, we see like 10 different modeling tools, right? We have a scikit-learn, we have PyTorch, we have TensorFlow, and TFX is more bound to TensorFlow.
correct,
Now, in that case, if you really see, right, uh, rather building like TFX as one MLOps pipeline and other things more custom built, right? So, what do you suggest? Like having a custom built pipeline for everything really simplifies the organization process as well. Say if I have like scikit-learn today, what we do in our MLOps pipeline is we have the training code. The training code will create infrastructure, whether it's cloud, AWS, or GCP, or Kubernetes, and then it will start the training. And after that, it will check in the artifacts into the repository, and the artifacts repository will do a continuous deployment pipeline onto
correct,
our production servers, right? So in those cases, if we are running only TensorFlow, it makes sense to have TFX. But if you have a hybrid modeling or algorithm tool,
correct.
I would say like a custom built also does a good job.
Yeah. I would say, I mean, so Shri, whenever, let's say, for more than 15, 16 solutions that I have built so far running in production, there, whatever I've done is I have preferred Airflow first before anything. I mean, because I agree with the fact that Airflow is easy to do. It's more Pythonic. No hard feelings with Kubeflow. Kubeflow is new, but it's more like, it's more, you could say it has a lot of horsepower, but it also comes with a lot of knobs and switches and keys and everything. You need to choose the best thing so that you can set it up. I know people find it difficult to set up Kubeflow. I have not set it up myself. I mean, there's in GCP there's an option to start Kubeflow AI pipeline. That's the thing which I usually do. But setting up Airflow is quite easy. It has a lot of customization with that part. And again, which so she already covered it. If it's not TensorFlow, then definitely you can't use TFX. You have to go with Airflow, or MLflow isn't preferred on that route.
No. Yeah, I think that's the question we have. There's one more question that came in. So, don't you think it makes things complicated as we are using TFX, Airflow, Kubeflow, KH? Shouldn't we try to use minimal tool to reduce complexity? So Rohit, this is a good question, right? Even if you take a typical MLOps pipeline or any tool, right? Forget TFX. When we talk about model, right? You have a huge data engineering pipeline that sits, and then we also have our feature engineering pipeline that we have it within our notebook. Typically, the data engineering pipeline is the one that starts creating the feature store and everything, right? And the feature engineering pipeline then takes those feature and again adds more feature to it, and all. So the pipeline itself is complex. So if you want to take the same pipeline and reproduce across multiple environment, create the continuous training loop and all. It kind of complicated, but it's a one-time setup. Over the time, it makes it simple, right? So yes, it might be complex, but even if you take non-TFX, you still have to build something similar to the TFX pipeline or something like that, right? To make it happen, so that it's reproducible. That's what I feel, Rohit. Uh, you want to add anything, Hasan, on
No,
top
no,
of?
I think that covers everything. So, I mean, I would say for starters, my first thing is for anyone who is starting new, start with TensorFlow first. Forget even about TFX or anything. Build a very simple pipeline, build a very simple model, then convert it into a pipeline. A pipeline means that if you are loading data in that model, which is more than your RAM, and you're successfully able to train a model, that means you have built a successful expandable pipeline. After that, try to convert that pipeline into an ML flow model, let's say, or into a TFX model. And after that, move it to Airflow or Kubeflow. So there are multiple steps in it. You first start without MLOps, then you start with MLOps, then you pick up a framework with MLOps, which will be as easy as Airflow, and then you build it to Kubeflow. So steps to it.
Right. And if an organization is actually going to develop only two or three models, then yeah, the complexity can be completely reduced, because we might have manpower to sit and monitor the model and and the models are not very dynamic.
Right.
Uh, but one of the projects that I have worked on, like we had 70 to 80 models in the customer. Like it's very difficult to do that manual. Then that's where even though it looks complicated, this one-time setup really helped us accelerate the model development, monitoring, retraining, and all
Mm,
the aspects of it, right? So that's where it comes into play. If it's simple solution, very few models, we can have like one-off custom solution as well.
correct.
Yeah, I think that's what we have, Hassan, right? And once again, Hassan, thank you for the session. It was a complex topic, frankly. Like it's not like a typical TensorFlow or a scikit-learn pipeline that we built. TFX
Correct.
has a lot of moving parts, and you covered it very well, taking us through each and every step of it. Thank you very much. Thank you for taking time on
Mm,
Saturday, and thank you everyone who are here to stay so late. It's almost more than hour and a half. Thank you for staying till the end and watching it. Uh,
correct.
yeah. Thank you all.
Thanks a lot. Bye.